Hello class, good afternoon and welcome to yet another session. Thank you. We are going to be talking about maximum and minimum values today. Maximum or minimum values of a quadratic function. The maximum or minimum values of a quadratic function equal to f of x equal to ax squared plus bx plus c are the values of f of x at the top or bottom of the curve. These are called the turning points of the function, okay, or of the curve. So you can notice these are the curves, whether downward or upward. If it is a maximum value, then we talk about something like this. If it is a minimum value, we talk about something like this. Can you see? And this occurs when a is greater than 0 for minimum value, a is less than 0 for maximum value. We have discussed this thing several times in our previous classes. Now, what is the minimum value of 3x squared minus 4x plus 1, and for what value of x does it occur? This is a first example, okay? This is the first example we're going to solve. All right. We will let y equal to 3x squared minus 4x plus 1 first. And the first thing we should know again after that is that the coefficient of x squared is 3, which is greater than 0. If it is greater than 0, then it's talking about a minimum value, and this is the curve for minimum value. Can you see? So that's the first thing, because a is greater than 0. So y is equal to this. I can manipulate this. The first manipulation is to factor out or to make the coefficient of x squared 1. The only way you can achieve that is factoring out 3. Put it outside the bracket. So now you can see I put it outside the bracket, and the coefficient of x squared is now 1. In doing so, these other terms will be affected. You now divide each term by what? 3. So you are doing that 3 like this. Divide each term by 3. So that's to keep a balance, right? All right. So the next step is to complete the square. Completing the square between this term and this term. How do you complete the square? To complete the square between this term and this term, you first of all find the coefficient of x. What is the coefficient of x? Minus 4 over 3. Minus 4 over 3, half of it is what? Minus 2 over 3. You would square it and add it to these two terms. I have done so. Can you see? This 1 over 3 is the extra term. It is here already. I dropped it. But because you have added something new here, you have to subtract it again to keep a balance. Okay? The whole idea is to complete the square here, to make this part a perfect square, right? And this is now a perfect square. This is now a perfect square. So because it is now a perfect square, I can now write it as y is equal to 3 like this, a bigger bracket. Then I'll take this and this because it's now a perfect square. X minus 2 over 3. I square it. Can you see that? Then I have plus 1 over 3. I will simplify this. Minus 4 over 9. This is what we'll have. All right. And this becomes y equal to 3 bracket, bigger bracket now, x minus 2 over 3 squared. Then I'll simplify this. Plus, you see, I'll find the LCM here. The LCM here is 9. 3 in 9 is 3 times 1 is 3. Minus 9 in 9 is 1 times 4 is 4. See? And so we can now have y is equal to 3 like this. X minus 2 over 3 squared minus 1 over 9. This is the function. I've written the function in this form, so I can now take this 3 back into the bracket. So we can have y is equal to 3 bracket x minus 2 over 3. You multiply 3 by this whole thing, then minus multiply 3 by this, it's going to be 1 over 3. So this is the required form. The next step here is to find the maximum value. Maximum value occurs when this whole thing becomes 0. And this whole thing becomes 0 when x is equal to 2 over 3, right? When you set this whole thing is equal to 0. So set x minus 2 over 3 equal to 0, i.e. x is going to be equal to 2 over 3. So that's it, okay? Now, you see x is equal to 2 over 3. That means that, therefore, y minimum is going to be equal to this term if this becomes 0. It's going to be equal to minus 1 over 3 at x is equal to 2 over 3. Thank you.